All right, hi everybody. Today's quick video will just be laying out what you're going to be doing today, do Friday, and a couple of quick notes on the lesson just so you make sure you're on the same page. So we're in our classroom. In the classwork tab, like usual, the first thing you're going to see here is the answer key for the homework you submitted and the link, which is not there yet, to the Zoom meeting for the 9:30 session for anyone who wants to jump in and ask some questions. So check your work there. That's the first thing you should do. I'll also be posting our new assignment. So there's a bunch of directions there. I'll read those carefully. Let me open this up so you can see everything that's in there. This video that I'm doing now will be at the top of the feed there. But below it is a bunch of stuff. I tell you all about what that is in the paragraph up top. So note packets, completed notes, this video, the Desmos activity. So all this will be in there. It'll be due Friday at 7 a.m. So hopefully things are going well. And you can pause for a second if you need to print up the note packets or get some blank paper out. But I'm going to go over to our notes. So actually I'll pause for a second just so you can take a look at a couple things I'm going to do in a second. So go ahead and get that ready to go now. All right, so hopefully you're set up. I'm just going to look at this first one. There's not too much new from what we talked about last lesson. If you felt good about that, you should be all right with this. Today I'm going to give you some information, whether it's given the transformations and given the characteristics from the graph or actually given a graph, we're going to write the equation of it. Friday, I'm going to give you a little activity, and that will require that you have a good grip on what we're doing today. All right, so I don't know if your packet came out this way or not. Everywhere there's a P in mine, that should be the pi symbol. So if yours came out like mine did, just fix those up. Those should all be pi's. So for the first one, write an equation of the cosine function. And so I mentioned that in the write-up for today's lesson. These are periodic functions. So if I just make a quick rough sketch here, if there was a transformation, let's say the graph looks like this, and obviously it would continue going back this way. I could see this as a sine curve starting here, right? That would be my one period of a sine curve starting at 0. Or I could actually see this and write this equation as a cosine curve. So in my answer key, my work for tonight, you could write these as either sines or cosines. The only difference is the phase shift will be different. All right, so I'll either be starting the sine curve there or I'll be starting a cosine curve there. All the other characteristics will be the same. The period, the amplitude, the vertical shift, those will all be the same. All right, so for the first one, I'm asking you to write a cosine function. So we know my amplitude is 3.5. So the amplitude A is 3.5. So from the midline, so the halfway point of our graph, it's going to go up 3.5 units from that center line and down 3.5 units from the center line. My phase shift, so that's the H value, we're going left pi over 4. All right, I'm going to come back to that period in a second. My vertical shift, that's my K, is a plus 9. So that's the majority of what we need. The key here is the period. This is where we have to be careful. Remember, our formula for period is 2 pi over b. So the period is different from the frequency. All right, the b value, the frequency, is how many cycles the graph completes over 2 pi, over kind of our traditional 2 pi. But what really helps us when we're graphing is the period. So in this case, we know the period is pi over 2. We have to kind of work backwards here and solve for b. All right, so whether you kind of think about it as cross multiplying, you can multiply by b on this side and by 2 on the other side to get those denominators to go away. Either way, we're left with 4 pi equals b times pi. I divide both sides out by by pi, and I get b equals 4. So the frequency is 4, the period is pi over 2. So really that's all there is to it. I have everything I need. So I know my function y equals, or f of x equals, my amplitude. my frequency, my shift left, pi over 4, and my shift up 9. So amplitude of 3.5, frequency of 4, shift left, pi over 4 units, the phase shift, and then a shift, vertical shift up 9. So that would be where the midline of this graph is. Okay, so if you want to try a couple more of those out, I think on the homework I asked you to do the odds on this worksheet. You know, if it's taking you way too long, then you can stop. I just want you to get an understanding of how we did this. And then we're also going to do a couple off that other worksheet with all the graphs on it. So you can go ahead and pause again right now. Make sure you are on the same spot as I am. And then we're going to try a couple examples on this worksheet. So when you're ready, I think I'll save number 1 for you. Number 1's pretty straightforward. Let's take a look at number 4 together. So we still need to get all the same information. We need to determine the vertical shift. So this graph actually, oh no, it is scaled. It's just kind of hard to see. There's 1, there's -1, there's our midline. All right, so that's an important thing to look for, that midline, the midway point of the graph. All right, so I'm not drawing it down here. It's not the bottom or the top. It's not the max or mins. The midline is that exact halfway point, kind of the average of the high and the low. So my midline here is right at 0, so we know the K value is 0. There's no vertical shift up or down. It's also up 1 and down 1 from that midline, so I know my amplitude is 1. So pretty straightforward so far. The only things we need to think about now are the period and the phase shift. So when I'm looking for the period, we want to look at how long it takes to complete one cycle. So there's a couple different ways to do this. So there's the origin. There's 0, 0. It looks like I have a nice point I can plot there at pi over 3. I have a nice point I can plot there at 4 pi over 3. I have another nice point I can plot there at 7 pi over 3. So it looks to me, if I were just to kind of pick my chunk here, we can decide wherever we want to pick. It looks like that's a really nice chunk of this graph that we can investigate. So if I look my halfway of this graph right there, from pi over 3 to 4 pi over 3, right? Pi over 3 to 4 pi over 3 is 3 pi over 3 of distance, which is just pi. So half of my period is 1 pi. And if I were to take it all the way, from 1 pi over 3 to 7 pi over 3, that difference there is 6 pi over 3. So my whole graph there is 2 pi. So that's actually our usual kind of traditional period. So our period here is 2 pi. So we don't really need to show this. We know that that's going to mean the frequency is 1, but just so you know for the future, when you do these, we have to set this formula up again, just like I did in the last example. So we know 2 pi over b has to equal my period 2 pi, so clearly we know that b equals 1. And last thing, if we were looking at this as a sine curve, right there, we have a shift right of pi over 3 if we looked at it this way. So my h value, we're shifting right by pi over 3. So putting it all together, I have y equals, my amplitude is 1. I'm seeing this as a sine curve. If you wanted to mess around with it, you could also write it as a cosine curve starting here, so the shift would change. But I think this one's a lot easier to write as a sine curve because we clearly see that starting point. My amplitude is 1. My frequency is 1, so I don't have to write that either. I'm shifting right by pi over 3. And I'm not shifting up or down at all. So I think that's all I have to do. We could also take it a little further. We could shift it right by 4 pi over 3. But that would mean this graph would have to have a reflection in it. So I could also write this as negative sine of x minus 4 pi over 3. So in the answer key that I'm going to post on Friday, you'll see I'm going to write these in several different ways. So that's why I'm doing that, because there's a lot of different ways to write these questions. So hopefully that made sense to you. I'm going to flip to the next page I would like you just to start thinking about number 7. I'm going to pause for a minute, and then when I unpause, I'll have a little bit of work up there. But try number 7 on your own, see how it goes, and then that'll be it for my little mini lesson here. So go ahead and try that now. All right, so this example has a vertical shift down 1. So my green dashed line is where that midline is. So like I said before, I didn't make this line down at the bottom of the graph. We always look for that midline as the midway point of that function. So that's how I got my shift down 1. My amplitude was up 1/2 and down 1/2. From the top of each of these two curves, so that dashed line I made, I looked at this as like a cosine curve. You also could start it here and call it a sine curve, but I think it's a lot easier to see as a cosine curve in this case, with a phase shift right pi over 2. So my final answer here, my graph is y equals, my amplitude is 1/2. I think this looks like a good cosine graph with a frequency, I'm sorry, the frequency should be 2 there, my fault. B should be 2. With a B value of frequency of 2, a shift right pi over 2, and a shift down 1. So if you wanted to mess around with this, you could get Desmos out or your calculator out and try to write this as a sine curve. Try to do a couple different things. We actually could also write it as a cosine curve reflected with no phase shift. So there's really an infinite number of ways to write these. So hope that helps. Let me know if you have any questions, and yeah, we'll talk Friday. All right, see you guys.